Hello and welcome to helpyourmath.com. In this video, we are going to look at the special cases of solving linear equations in one variable. So one variable implies that we're only going to see one type of variable, whether we see x, a, h, and linear means that we won't see any exponents around that variable or radicals around the variable. It'll just be regular x, regular a, regular h. What types of solutions do we see for linear equations in one variable? Usually, like 99% of the time, we're going to see just one solution. So we might do all of this work and then at the end we get x equals 4, or we get a equals 6, or h equals 0. All of these imply that we have one solution. This is the most common type of solution we will see when we're solving linear equations in one variable. It's just one single solution. But there are two other cases to consider. One is we get here, so let's say, I'm going to say special case 1. I'll call it special 1. And what if we have x plus 4 equals x minus 2? And we say, okay, well, I want to get the variables together on one side. So then I go to subtract x. And wait, but when I subtract x from both sides, it cancels out here because x minus x is 0. 0 plus 4 equals 4. It also cancels out here. X minus x, still 0. 0 minus 2 is negative 2. Then I'm left with this. 4 equals negative 2. What does that even mean? That's not a thing, and it's not. You're right. The variable is gone. It canceled. It left a false solution. We might say this is a disjoint set. This implies that there's no solution, and we can just write no solution. Solution does not exist. If you're writing your answers in set notation, you might just do the empty set, not a 0, the empty set or the null set. But there's no solution here. There's no value we can plug in for x such that the left side is going to match the right side. In our other special case, so we're going to call this one special 2, what we're going to see is we're going to be left with something like a minus 5 equals a minus 5. And we go to combine get the variables together on one side. So I'm going to subtract a from this side to get it over here. And a minus a is 0. 0 minus 5 is negative 5. Over here, a minus a is 0. 0 minus 5 is negative 5. Again, the variables cancel, but this time we're left with a true statement. If we end up with no variables but a true statement, as we see here, that implies that there are infinitely many solutions. Infinitely many solutions, because every number you plug in is going to work. 1 is going to work. 0 is going to work. Pi will work. So we can either say infinitely many solutions, or it's just the set of real numbers, because everything is going to work. So you'll notice here that the two cases are when the variables cancel. So we're doing all of the work and all of a sudden we're left with no variables. That's when we get these special cases. At the end of the problem, if you still have a variable present, then you have one solution. All right, what's going to happen here with m? Let's find out. On the left-hand side, I'm going to clean up by distributing first. So 5 times m is 5m. 5 times negative 3 is minus 15 plus 2m. I'm just going to keep working on the left side and then I'll worry about the right side. I'm going to combine like terms here. 5m plus 2m is 7m minus 15. Okay, that's as simplified as we can get on the left side. Now let's look at the right side. The right side I have like terms. I have 4m and 3m. That makes 7m. And then the minus 9 I'm just going to bring down. So my simplified left-hand side equals my simplified right-hand side. I have 7m minus 15 equals 7m minus 9. Now I'm ready to move all the variable terms to one side. Maybe we want to move the constants at the same time. It doesn't matter, whatever you're more comfortable with. I'll do it one at a time. Okay, so I'm going to subtract 7m. That way I'm just getting all the variable terms on one side. Now I have 7m minus 7m, which is 0. 0 minus 15 is negative 15. Over here I have 7m. Wait a minute. These cancel. I'm left with, oh no. Oh no. So see, my variables canceled and now I'm left with this false statement. Remember what the false statement means? No solution. No solution. And we can kind of verify this. Hold on, let me get there. Okay, right here, I see 7m and 7m, that's the same number, right? So whatever 7m is on the left, it has to be the same 7m on the right. But then we're subtracting 15 on the left and we're subtracting 9 on the right. There's no number that I can subtract 15 from, and then that same number I subtract 9 from and get the same value. That doesn't make any sense. So it makes sense that there's no solution for this one. In this example, let's see what happens to h. I'm going to clean up my left-hand side. I have negative 3h plus h is minus 2h, or negative 2h, plus 14. On the right-hand side, I'm going to distribute the minus 7. So I'm going to write down 5h minus 7h. This becomes plus 14. I still have like terms here. 5h minus 7h will be minus 2h plus 14. Now I feel like I just repeated myself. Wait, I'm just writing the same thing on the left and the right. Yeah, that's the same thing, right? The left side matches the right side. I could take this a step further and add 2h to both sides, in which case we would be left with 14 equals 14. But what I'm getting the sense of here is that the left is going to match the right. Therefore, this is a special case. This one, there are infinitely many solutions. So I'm going to write infinitely many solutions. And again, what this means is that no matter what we plug in for h, if we plugged in 1, if we plugged in 0, 100, negative 94, the left side will always be the same as the right side. Every real number will work here. These have been the special cases for solving linear equations in one variable. Thank you for stopping by.